This is the November 2011 Unit 2 paper, number, algebra and geometry. Question 1 is an add-in fractions with different denominators questions. The most important thing when dealing with this type of question, if I zoom in, is to get the denominators the same so that you can work with them. Now, the denominators here are 5 and 7. The quickest way, if it doesn't jump out at you in the first place, the quickest way to get the denominators the same is by timesing those numbers together. So 5 times 7 is 35. So I need to rewrite both my fractions as fractions out of 35. Now, to get that 5 to 35, I timesed it by this 7. So that means I also have to times the top number by the 7 as well. So that becomes 7 over 35. And here, I times the 7 by 5 to get 35. So I need to multiply that 3 by the 5. So that would become 15. Now you can add fractions with different denominators easily, because the denominator stays the same. And you just add the top numbers, 17 and 15. 7 and 15 is 22. This is a 2-mark question. You get 1 mark for showing that you've got the denominators to be the same, and then you get your second mark for the answer. Now it is 22 over 35 with an OE next to it on the mark scheme, and that means or equivalent. So if you'd managed to convert that to a decimal somehow, or if you'd cancelled it down to something ridiculous, then you would still get the marks, but 22 over 35 is what you're aiming for. Question 2 is a lovely algebra question. Again, straightforward. Simplify 5f times 4g. Well, 5 times 4 is 20, and f times g is fg. 1 mark. Expand and simplify 9a plus 3 open bracket 8 minus 2a. First thing I'm going to deal with are these brackets. I've got positive 3 there times by 8, which is positive 24. And I've got positive 3 times by negative 2a, which will be negative 6a. I mustn't forget about the 9a I haven't used yet. So I end up now with 9a minus 6a, which is 3a. And then I've got my positive 24. That's a 2-mark question. You get 1 mark for showing a correct expansion of the brackets, and then you get the second mark for getting the answer right. Question C is a 1-marker. It's index laws. C squared times c to the 6. Well, because the big number is the same, or letter in this case, it's going to stay as c. And when you multiply index numbers, it means you have to add them. So that'll be c to the 8. Question D, again, index laws. This time you've got x to the power of 5 to the power of 3. Now we know brackets to mean multiply generally, so this is no different. You keep the x as it is and you multiply the powers. So it's 5 times by 3, which is 15. 1 mark. For question E, they want us to factorise, so that means we remove the highest common factor from both terms. So there's a 7y plus 21. What number goes into both 7 and 21? Well, 7 does, so that goes on the outside. Now 7 times y is 7y, and 7 times 3 is positive 21. And that's a 1-mark question also. Question 3 is a percentage question, but it's all about costing, and you know the maths is hidden in the problem here. So Priya is raising money for a charity by selling tomato plants that she has grown from seeds. She sells 48 tomato plants for £1.35 each. Priya keeps 15% of the money she gets to pay for the grow bags and seeds that she used. So she keeps 15%. She sends the rest of the money to the charity. How much money did she send to the charity? Well, the first thing we have to do is work out how much money she had in total. So the total money she sold 48 lots of £1.35 plants. So I need to do 48 times by £1.35. Now I'm going to forget about the point for now, and I'm going to do 135 multiplied by 48. Each number gets its own square, and there's a diagonal that cuts through each square. So 5 times 4 is 20, 3 times 4 is 12, 5 times 8, 40, 3 times 8 is 24, 1 times 4 is 0,4, 1 times 8 is 0,8. Add them together from this direction, diagonally, so there is a 0. There is a 0, a 4 and a 4, so that's 8. That's a 2 and a 2 and a 2 and an 8, which is 14, so I put my 4 down, carry my 1. Here I've got a 1 and a 4 and a 0 and the 1 I carried, and that gives me 6, and there I've got a 0. So my answer is 6, 4, 8, 0. Now I'm dealing with money here, and I've got to put the decimal back in. So there's a couple of ways of doing this. I did have originally £1.35. What I did is multiplied that by 100 and move the decimal point out 2 spaces. So in the answer I need to move the decimal point back in 2 spaces. So divide that by 100 again back in. Or if you are pretty good with this lattice method, then you can realise that the decimal point originally started there. And on this, because we're dealing with 48 plants, there would be the decimal there. If you trace the 2 decimals to where they meet, and then their diagonal line, that will also tell you where the decimal goes. So overall she takes £64.80. Now she keeps 15%, so she keeps 15% of £64.80, and I'm just setting it out like this so the examiner can see exactly what it is I'm doing. If I've got the wrong answer up here, then maybe he'll give me some method marks here. So in order to find 15% of something on a non-calculated paper, I need to first of all find 10%. Now to find 10% you divide by 10, so that's £6.48. I then want 5%, which is just half of 10%, so it's £3.24. Now in order to get 15%, I just add my 2 percentages up, because 10% plus 5% is 15%. And then over here, I can do, I've got 8 plus 4, which is 2, or 12, carry the 1. There I've got 4 plus 2, which is 6, and my 1, which is 7. My decimal point needs to stay underneath my decimal points. And here I've got 6 and 3, which is 9. So 15% equals £9.72. So that's what she keeps. Now the question wants to know, how much did she send off to the charity? So I'm just going to do another heading here, charity. And the charity get the £64.80, take away the £9.72. So 0 take away 2, well I can't do that, so I need to consider my tens and units, whatever you want to call it, borrowing. So I've got 10 take away 2, which is 8. Then I've got 7 take 7, which is 0. Decimal stays under the decimals. I've got 4 take away 9, which I can't do. So I'll go next door. That becomes a 5. This becomes 14. 14 take 9 is 5. And then I've got that 5 take away nothing is 5. So charity gets £55 and 8 pence. With regards to mark schemes for this question, you get 1 mark for showing a complete method of doing that multiplication. You get an accuracy mark here for getting the answer to the multiplication correct. Then you get a method mark here for showing a clear method of getting to 15%. Then you get a method mark over here for showing that you are aware that you need to subtract the amount that you found from the original amount. You then get an accuracy mark here for having the 55.08, the answer to that sum, and then there's an additional A1 mark for the correct answer. And that's it, 6 marks. Question 4 is quite a complicated area question, but it's only complicated in the way that they've presented it to you. It really is nothing more than an area of a trapezium. Now, just to remind you, this is a trapezium, and a trapezium has a set of parallel sides, and in order to find the area of it, we need the perpendicular height. Okay, so Jake makes a picture frame from 4 identical pieces of card. Each piece of card is in the shape of a trapezium. The outer edge of the frame is a square of 12 centimetres. So that's the outer edge. The fact that they've said it's a square means this is also 12. The inner edge of the frame is a square of 8 centimetres. So there's the inner edge. And that means that every inner edge is also worth 8 centimetres. Work out the area of each piece of card. So we need to find the area of one of those pieces of card in the shape of a trapezium. Now, I know the area of a trapezium is the 2 parallel sides added together and divided by 2, multiplied by the perpendicular height. So let's have a look. Let's take this trapezium here. I know I've got these 2 parallel sides. That's 12, that's 8. So I've got the 2 parallel sides I need there. However, I do not have a perpendicular height. In order to find that, I need to consider the difference between the inside rail, the inside frame, which is 8 centimetres, and the outside, which is 12. So the height of the trapezium is going to be the 12 centimetres of the full frame, take away the 8 centimetres of the inside frame, and that leaves us with 4 centimetres. However, it's not 4 centimetres as the height of the trapezium. As you can see, we've got 2 lots of space. Let me make that thicker. 2 lots of space, which that 4 centimetres has to be shared between. So the height of one of the trapeziums is actually only 2 centimetres. So I'm going to go ahead and write that in there. 2 centimetres. Now what I end up with, if it's not clear already, is a trapezium with 12 there, 8 there, and a perpendicular height of 2. So let's just find the area of that trapezium. I do 8 plus 12 divided by 2 times by perpendicular height, which is 2. 8 plus 12 is 20 divided by 2 times 2. 20 divided by 2 is 10 times by 2 equals 20 centimetres squared. So that's your answer. Now, the more observant of you may have recognised the fact that if we're doing 8 plus 12 divide 2 and then we're multiplying that by 2, then they're going to cancel each other out and you'll just be left with 20. But if you can't spot that, don't worry, follow the method through. And the marks for this is only a 4-mark question, and you get 1 mark up here for finding the height of a trapezium, you get the mark for stating that the height of the trapezium is 2. You then get the third mark for showing that you needed to find the area of the trapezium, and then you get the final mark for stating what the area is. Now the answer line gives you centimetres squared. If it didn't give you centimetres squared, this would be a 5-mark question, and one of the marks, independent of any mistakes you've made, one of the marks will be you putting centimetres squared on the line. So don't forget to keep an eye out for that. Question 5 is sequences and an nth term question. Here are the first 4 terms of an arithmetic sequence. That means it goes up by the same amount each time. It's like an add-in sequence. Find the 10th term of this sequence. Now, it's a 1-mark question. You've got 2 options. You can either realise there's 1, 2, 3, 4, and then keep adding 6 until you get to the 10th. Fine, that's one way. I, however, would rather, whenever I see a sequence and they're asking me to find the anythingth term, I'm going to look for the nth term. And it just so happens that part B wants you to find an expression in terms of n for the nth term of a sequence. So that's what I'm going to do from the start. So first thing I need to do is find my common difference. That's gone up 6. That's gone up 6. That's gone up 6. So I know that my common difference is 6. Now, the other sequence that we know that goes up in 6s is the 6 times table. So if I considered the 6 times table in place of the times table I've already got, I'd have 6, 12, 18, 24. And the 6 times table is represented by 6n because it's 6 times by any number. So in order to find out what is plus or minus on that 6n, I look at the 6 times table. What do I do to get from the 6 times table to my sequence? Well, to get from 6 to 10, I add 4. To get from 12 to 16, I add 4. 18 to 22, add 4. That means my sequence, or my nth term, sorry, is 6n plus 4. So I'm going to go ahead and write that in part B for now. Now I'm going to use that to work out the 10th term. So the fact that it's the 10th term means I'm looking for the number 10. So I'm looking for the 10th position. So then I just substitute that in. 6n plus 4 means 6 times 10 plus 4. 6 times 10 is 60. Add 4 equals 64. So the 10th term is 64 and my nth term is 6n plus 4. Now this is a 1-mark question. You just get 1 mark for the 64. This is a 2-mark question and you get 2 marks if you manage to get the nth term correct, or you can get a B1 mark if you manage to get 6n plus a number that isn't 4. Question 6 is about the application of a formula, and then the fact it's got a star next to it means that they want you to do a write-up at the end. So this formula is used to work out the body mass index, B, for a person of mass, m, kilograms, and height, h, meters. And there it is, B equals m over h squared. A person with a body mass index between 25 and 30 is overweight. Arthur has a mass of 96 kilograms, a height of 2 meters. Is he overweight? Show all your workings. So let's have a look. That's the formula. I'm going to write it out here in my own handwriting. B equals m over h squared. Now in order to work out his BMI, we need to know that his mass was 96 divided by his height squared. His height is 2 meters, so 2 squared. So what we end up with there is 96 over 4. So 96 divided by 4. Well, I know 96 divided, I know 100 divided by 4 would be 25. And I've got 4 less. So that is 24. The fact that his BMI has come out as 24 means I now need to comment on that, because here it says that overweight is between 25 and 30. He's 24, so I can make the final statement that no, Arthur is not overweight, as his BMI is only 24, full stop. With regards to how marks are allocated for this question, you get a method mark here for showing that you've subbed the right values into the formula. You get an answer mark for 24, and then you get a communication mark for writing your sentence.